Welcome to the new course, Fluid Mechanics. Myself, I am Dr. Madhusudhan Reddy, working as Assistant Professor in the Department of Civil Engineering in Institute of Aeronautical Engineering. So, the present course is actually targeted to the undergraduate students of Civil Engineering and as well as Mechanical Engineering. So, before going to this, enter into these various topics in this particular course, Fluid Mechanics, first we will see what is the course outline and then how it is going to be used to the students. So the fluid mechanics is an interdisciplinary course, so which covers the basic principles and as well as the applications in civil engineering and mechanical engineering and chemical engineering also. So which covers the basic principles of application oriented principle in case of civil engineering, mechanical engineering and as well as chemical engineering. The students will have new problem solving approaches like control volume concepts and as well as streamline patterns which are nowadays required to solve the real life complex problems. So the visualization of the fluid flow, problems will be demonstrated to enhance the students' interest on this subject. So in a simple way, this particular subject, the particular fluid mechanics subject, is enable the students to understand the flow pattern, flow types, then what are the various types of flows, then what are the forces that can be acted by the force on the fluids and as well as gases. So various topics involved in this particular subject. So this is mainly concentrated on undergraduate students and as well as undergraduate students of civil and mechanical engineering as well as the chemical engineering. So the course objectives. Coming to the course objectives, once after completing this course, fluid mechanics, the students will try to learn the fundamental knowledge of fluid properties at rest, fundamental properties of the fluid at rest, and in transit for various conditions in both the closed and as well as open channels. So the fundamental concepts of the fluid at rest. So when the fluid is in at rest, at the same time when it is closed, when the fluid is in condition of both closed and open channels. So the student is able to learn the concepts of the is able to gain the concept and how the behavior of the fluid even in the rest, in case of open channel, in case of closed channel. So you will get into know after this course. So the concepts of buoyancy and as well as stability of floating bodies and the forces acting on the immersed bodies by employing the concepts of pressure. So the buoyancy force, how this buoyancy force is influence the how is acting on the fluid. Then stability of floating bodies, various stability of floating body will be discussed in this fluid mechanics subject. And then the basic law of continuity and energy, momentum and their governing equations. So along with these two, and the another important thing is in this, the basic law of continuity and as well as energy and momentum and their governing equations. So the continuity equation and as well as energy and momentum equations will be discussed in this particular subject. And the analysis in intensive extensive properties by basic bifurcation and simulated the fundamental knowledge of fluid properties at rest in transit for various conditions in both the closed and as well as open channel. This is somewhat repeated, so no problem. So here the student will try to understand the property of the fluid when it is rest and when the fluid is in closed condition and when the fluid is in opening channel. And at the same time, you will get to know when the body, some floating bodies are immersed in the fluid, then how the body will behave and what is the center of gravity, center of forces acting on that body, that will be studied in this particular topic. And then the basic continuity equation and the energy and as well as momentum equations will be discussed along with the Bernoulli's equations. These are the various concepts will be discussed here, and these are the various outcomes, objectives will be gained by the students after completing this course. So coming to the course syllabus. So we are particularly dealing with these topics. The first module is about properties of the fluid. In this we will discuss about the basic distinction between a fluid and as well as solid and properties of fluid, what are the various properties like densities, and then unit conversion also we will discuss, intrinsic and as well as extrinsic parameters of the fluid, and as well as Newton's law of viscosity with the classification of cavitation, surface tension, capillary, bulk modulus, elasticity, and as well as compressibility, the major topics in this. So there are few other minor topics also we'll discuss it here, like what is the difference between the gases and as well as fluid, what is the difference between the solid and as well as fluid, and then uh, along with this topic we will also discuss the basic definitions like stresses. So then fluid statistic, there are various classifications of the fluid mechanics that we will see in the coming slides, and our module 2 is designed for fluid statistics. In this we will discuss the fluid pressure, and this pressure at a point and as well as Pascal's law of pressure measuring devices. What are the various devices which we use to measure the pressure, and piezometers, different type of manometers to measure these pressures, and as well as hydrostatic pressure for a submerged bodies. Hydrostatic pressure for a submerged body, buoyancy and as well as stability of the floating bodies will be discussed in this fluid statistic topic. And coming to the module 3 is about to fluid kinematics. Module 3 is about the fluid kinematics. So in this topic we will discuss about the classification of the fluid flow with respect to the time, space, rotation about its axes. Classification of the fluid with respect to the time, space, rotation, and as well as about its axis. So these there are different type of fluids classified based on these parameters, based on these time, space, and as well as rotation parameters. That also we will discuss in this module 3. And along with that, the Reynolds number, Froude number, and the combination of the fluid flows, whatever the classified various classifications are there, if they the combination of those also we will discuss in this. And the flow patterns, Laplace equation, and flow net, derivations of continuity equation, as we discussed. The continuity equation is like A1 V1 equal to A2 V2. So this is the basic equation. Then the derivation of this equation also we will discuss in this particular module. And the module 4 is about the soil dynamics, whereas previous one kinematics, before that is kinetics, and now it is a dynamics. So now it is a part of dynamic. So in this dynamic part, we will discuss about the surface body forces, law of conservation of mass and energy, in an equation of the motion, Euler's equation, and derivations of the Bernoulli's equation, momentum equations, and then and at the same time we will do some problems on this real time problems with the fluid, and then after by applying this Bernoulli's equation and the momentum principle application also we will discuss in this module 4. So coming to the module 5 is about the flow through the pipes. So in this while discussing this module 5, the flow through the pipes is about we will be discussed about in this module is major losses, derivation of Dawes' Wishbesh equation, and minor losses through the pipe, and pipe in series, when the pipe is in equivalent pipe, when the pipe in parallel. We will do some analysis of pipe networks. We will do some analysis on pipe network using this Ardygrass method. These are the various topics we will discuss in this module 5, and this the major out of the very important topics about this is the entire syllabus is basic introduction, just basic introduction. I mean, in this introduction, in this we will discuss what is meant by the fluid, what is fluid, and as well as difference between the fluid and as well as solid, solids. Then the fluid types of fluids we will discuss, types of fluids, and as well as in this types of fluid again we will discuss about the liquids and as well as gases. So the difference between these two we will discuss in this module 1. So coming to the module 2 is about the kinetics. Fluid statics. So here various pressure meters we will use to measure the pressure, and along with that Pascal's law also we will discuss in this module. So these are the various fluid kinematics topics which the flow types is based on the time, space, and as well as rotation, And in this module 4 is about the dynamics. We will discuss here surface, body, and forces which are acting on the fluid. So then, while those forces, if they're acting on the fluid, then the governance of the fluid, how will the fluid will behave, that also we will discuss in the module 4. And coming to the module 5 is about the we will focus on major losses through when the flow of fluid through a certain pipes. So we will focus on the major losses, that to how to calibrate those and how to reduce those. Also we will discuss here. And then pipe networking method using anti-crash method. These are the major topics that we are going to discuss in this module 5. So coming to the suggested textbooks are for this fluid mechanics subject is Modi and Sethi, which is published in 2019 by the Rajsans Publications, and then A.K. Jain and by the Kanna Publishers. So then another one is Ramamrutam textbook on the hydraulic fluid mechanics and the fluid mechanics. So Danpatrai published publication, this one is. And there are few web references. If you are anyone interested, then go for these web references. You can also see these web references. So these are the various publications. There are some other textbooks are also there, like Modi and Sethi Volume 2, and then Ashok K. Jain already mentioned here. So they were. So coming to the basic definition. So first we need to know what we are discussing about the fluid mechanics. First we need to know about what is meant by the fluid. So here the fluid it is a substance which can deform continuously under the action of a shear force or tangential force. So when suppose if you take some fluid here, suppose if you apply some load, and this is continuously when continuously under the action of shear forces and as well as tangential forces, it is substance can deform. It is continuously deformed due to the application of this external load. Under the action of the shear as well as tangential forces. And however, for small shear force, maybe it may deform. For small shear force also, this may be deformed. So it is a substance. It is deformed continuously. It is a substance if it is deformed continuously, and this fluid may be a liquid and as well as gases, and fluid don't have any shape. So fluids don't have any shape, but it may be a liquid and as well as gases. So the fluid is may be a liquid and gases. Fluid may be a liquid and as well as gases. So before going in detail about this liquid and as well as gases, first we will see what is the difference between the fluid and as well as solid. So as I told, fluid is a substance which is continuously deformed when you apply the load. When we apply the load, the fluid is gets deformation due to the application. This deformation is depending upon the load, amount of load which we applied on the the fluid. So coming to this solid, so solid also gets deformed, but due to some internal resistive forces, this is depending upon the load and as well as for example, if you take this is a solid body and if you apply some load on it, then due to this opposite reactive forces, it may not get that much of deformation. So to get the deformation of the solid body, whatever the load we are applying, that must be greater than this resistive force of the body. So the deformation, a fixed amount or break completely when stress is applied on it. So whether it may deform or maybe break completely. So when it breaks, actually when the applied load is greater than this resistive force of this body, so then only it will be break. Otherwise, we will get the small deformation, like the deformation, like you may get some cracks may be developed here, something like that. It may be deformed. Whereas coming to the fluid, it deforms continuously as long as any shear stress is applied. So fluid is deformed continuously, even for the small shear force also maybe I get deformation. So whereas solids are not like that. It may be the deformation of the solid is purely depending on the amount of load which were applied on the body. So those are the basic differentiation between the fluid and as well as solid. And coming to the stresses, coming to the stress, as we all of you know that the stress is defined as a uh, uh, force per unit area or load per unit area or load per unit area. So, so these CS, the stresses basically shear stress, tangential are tangential stress and then there are normal stress. So here the force acting parallel to the surface per unit of the unit area of the surface. Here it is simply defined as the force acting parallel to the surface per unit area of the surface, whereas this normal stress is a force acting perpendicular. So where the normal one is acting when the force is acting in this case, and whereas it is perpendicular. The shear stress is, suppose for example, if you take any body, like I'm just considering some solid here. So shear stress, it is a shear stress, so parallel to the body, whereas this one is perpendicular it is normal to the perpendicular to the surface unit area of the surface. This is about the normal stress and as well as shear stresses. So coming to the basic definition of the stress, suppose if you consider small area, if you see from this figure 1, if you consider small area from this entire body, I have considered only a small area of delta A. So this this delta is a small area on the surface of the body. The force acting on this area, suppose for example, if you say there are some few forces are acting on this body in this particular area which we selected, delta A area. So the force acting on this body is a delta F. The force acting on this area is a delta F. This force can be resolved into perpendicular and as well perpendicular components. So this whatever the force F is acting on this particular body, this can be resolved in a two perpendicular components. So those are normal and as well as tangential. This is the force is acting. The force is acting on this particular body and they resolved in two components. One is normal and as well as tangential. So the component of force acting normal to the area is called normal force. This one, which is acting normal to this area, is called as a normal force and is denoted by the delta F n, normal force acting on the normal. So then the component of the force acting on the plane of area is called the tangential force. And it denoted by the delta into Ft. So when they are expressed for as force per unit area, as I told, the definition of this stress is equal to load per unit area or force per unit area. When these expressed in terms of force expressed as a force per unit area, they are called as normal stresses and as well as tangential stresses respectively. So then how we will expressing these things? So load per unit area, for example, if you want to express this normal stress, it will be load per unit area delta A, or this is tangential delta A. So unit area is which we consider delta A, and then we are expressing whatever the resolved forces, whatever the force is acting, each is actually resolved in two components, perpendicular components. One is normal, the other one is the tangential. So then the tangential stresses is also called as the shear stress. Shear stresses. So coming to the basic definition of the fluid. So as of now we discussed fluid is a substance which deforms continuously, and the fluid may be a liquid and as well as gases. So if you see the basic definition of the fluid is a substance that deforms continuously in the face of tangential or as well as shear, irrespective of the magnitude of the shear stress. It deforms continuously, and these continuous deformation under the application of shear stress constitute a flow. So when if you see this figure 2, and this is about fluids. So this is the permanent place, whereas shear stress is acting in this direction. And you see initially it is 0 to in, if the shear stress tau is applied, if tau is applied at any location of the fluid, the element, if you take this element 0, 1, 0, 1, 1 dash, and element 1 dash which is initially at rest, this is initially at rest, will move to the, because of this application of the shear stress, when the fluid element, this one initial element will move to the 0 to 2 dash. If you apply continuously, again it move to the 0, 3, 3 dash. This is the and further is, from this figure is, further is 0 to 0, 4 and 4 dash. And the continuous to move the similar fashion. Similarly, if you, in case it may be go like this. So it will be 5 dash, 6 dash, and as well as 7 dash. So in this connection, the fluid can also be defined as a state of matter that that cannot sustain any shear stresses. So the basic definition. So when you apply the shear stress, the fluid body may move from different from the origin to different okay. And in other words, continuation to that previous slide, in other words, the tangential stress in a fluid body, the tangential stresses in a fluid body depends on velocity of the deformation and as well as vanish as this velocity approaches to 0, as this velocity approaches to the 0. So if you see some basic differences between the solid and as well as fluid. So here the deformation, solid will get the deformation depending upon the amount of load which you are applying, but this fluid is get continuous deformation. And more compact structure, the solid is a more compact structure. It is like there are it is like, whereas the fluid is less compact structure. Attractive forces between the molecules are larger, therefore the more closely packed. So the attractive forces between the molecules in case of solid are very larger, and therefore the solid body is more closely packed. And attractive forces between the molecules in this case of fluid is very smaller, and therefore the more loosely packed. So attractive forces in case of fluid it is very small. So that's why it is loosely packed. Whereas in case of solid, the attractive forces between the molecules is largely very large. So it is closely packed. And solid can resist a tangential shear stress in static condition. So whatever the tangential load or shear load, if you apply on this body of solid, it resists somewhat. So it is resist somewhat, whereas the fluid can't resist the tangential stresses in static condition. The fluid can't resist the tangential stresses which we are applying on the fluid body. It can't resist. So whenever the solid is subjected to shear stress, whenever the solid is subjected to shear stress, for example, if you see this diagram, whenever the solid is subjected to shear stress tau, it undergoes a definite deformation or breaks. It may undergo definite deformation is alpha here, and or sometimes if it is the applied load is more than this internal resistivity of the body, then it is going to be deform break. And alpha is a proportional to the shear stress up to some limiting condition. The limiting condition, because when the resistivity power of this particular body, solid body, which is less than this applied shear stress, then will be the body will break. So that's why it is up to certain limit only. Whereas in case whenever a fluid is subjected to a shear stress, so there is no fixed deformation. And continuous deformation take place until the shear stress is applied. So if you apply the load continuously, the deformation will be observed in case of fluid, whereas in case of solid, it may break at a certain limit. So but in case of fluid, we will observe continuous deformation until the shear force is applied. So the solid may regain partially or fully its original shape when the tangential stresses are removed. So this body of solid may regain its original shape. Suppose whenever if it is within the elasticity limit, whenever within the elasticity limit, if you remove the load within the elasticity limit of the body, then there may be a possibility of regaining its original shape. So whereas in fluid, the fluid can never regain its original shape once it has been destroyed by the shear stress. Um, so when the fluid substance or fluid element, if any changes are occurred in terms of those changes will not be, whatever the changes happened due to the applied load, from that changes it never regain its original shape in case of fluid. The major differences are very compact, whereas it is very less compact, and due to the attractive forces, the larger the molecules are larger, that's why it is closely packed, whereas this is very loosely packed. And then the tangential stresses, solid can resist tangential stresses in static condition, whereas this fluid cannot resist those tangential stresses in static condition. When you apply certain load on this particular solid body, it may deform up to a certain limit. After that, it will break. Whereas if you apply certain same shear stress on this fluid element, and there is no fixed deformation, and as well as we will get the continuous deformation until the shear stress is applied. And whereas the solid possibility to regain its original shape of once after removing the load. In case of fluid, we can't see that kind of nature from the fluid bodies. So again, basic as I told, it is closely packed and it is very apart. The molecules, and coming to the liquids, are incompressible, and whereas the gases are the compressible. As of now, whatever we discussed, that is about the solid and as well as the fluid. Here it is liquids and as well as gases. So the molecules are in case of liquid closely packed, whereas in case of gases, compared to the gases, the molecules in case of liquid is very closely packed, but compared to the solid with the gases, loosely packed. So here it is different. In case of solid, compared to the solid, the liquid molecules are very loosely, but compared to the gases, the liquid molecules are closely packed. So liquids are incompressible, whereas the gases are the compressible. Liquids have definite volume, and in case of gases, we don't see any definite volume, whereas the liquids have free surface, and in case of gases, we don't observe any kind of free surface. So for example, if you take there is a free surface in case of liquids, free surface, whereas the gases you won't observe any free surface. No free surface. In case of gases, this is, you will observe the free surface, have some free surface in case of liquids. So here the molecules are closely packed in case of liquid compared to the gases, whereas here wide apart, the molecules are wide apart in this case of the gases, and these liquids are incompressible, gases are the compressible. And these are the various liquids have definite volume, whereas the gases don't have any specific volume, and these liquids have free surface, whereas the gases don't have any free surface. So this is the differences between the liquid and as well as the gases. Now we will see another two basic terms: cohesion and as well as adhesion. The cohesion is nothing but the attractive forces between the same molecules. So whereas attractive forces between the different molecules, the adhesion is nothing but the attractive forces between the different molecules in case of adhesion, and as well as cohesion, the attractive forces between the same molecule. These are the things need to be remembered here. So whenever attraction happened between the same molecule, that is nothing but the cohesion. Whenever the attraction happened between the different molecules, that is nothing but the adhesion. This is about the today class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.